Happy Monday, it's Mrs. Weekly here. So last week you guys worked on solving systems by graphing. This week you are going to be working on the second strategy called substitution, and it's exactly how it sounds. So substitution is I'm just replacing something, I'm substituting something in order to solve for the x and y values that solves the system of equations. So I recommend while I am going through this part to either get a notebook out of your notes and add it to your notes, or save this Jamboard so you have these notes available for when you're trying the activities and working on learning this strategy. So starting out with, so there's the 5 steps that you kind of see in front of you right now. The first step is to solve one of the equations to make it look like y equals, or I'm also going to add, it could be x equals, and this is going to make more sense when we do some examples. So we just need to solve for one of the variables, because once we do that, then we'll be able to do that substituting part, okay? And sometimes it's already going to be solved for you, so you don't have to worry about that. Second step is to blank the value for y in the second equation. So that means that we're going to substitute Okay, so it's either x or y, depending on what you have. Again, this is going to make a whole lot more sense when we do some examples. Third step is to solve the new equation. So basically what you did by doing these 2 steps was to get all one variable in the equation so you can solve for either x or y. Okay, so I'm going to add y here. Remember, it just kind of depends on what you started with. Next step is to substitute the value. So it's kind of a lot of substituting and solving. So depending on what you solve for, you'll be substituting in x or y to find the new x or y. And then last step is to check your solution. Okay, so these are kind of long problems. I'm going to give you a heads up on that right away. They do take a little bit of time, so we'll just keep that in mind. There are going to be some special cases similar to what you've seen before. So some of those equations might have one solution, no solution, or infinitely many. Okay, so for instance, that second bullet point says your friend is solving an equation and her last line of work says 2 equals 2. What does this mean? Well, you ask yourself, does this make a true equation? Does 2 actually equal 2? If it does, what does that mean? You guys know this. It's infinitely many. So in this case, if it's a true statement, we know that it's infinitely many. And that third and final bullet point of your note part, it says, as your friend is solving a different equation, the last line of work says 2 equals 1. Well, again, you're asking yourself, is this a true equation? Does 2 actually equal 1? In this case, it doesn't. So it's not going to be infinitely many. This one's going to be a no solution. Okay. So moving on to some examples. Again, I recommend having something out so you can do these examples along with me, or maybe watch the first one and try the second one with me. But make sure you're participating and doing some work with some of these, okay? So step 1, going back to that first slide of notes. Step 1 is to solve one of the equations for y equals or x equals, if necessary. Okay, so I'm just checking. And I'm looking at this first equation, and it already says y equals 3x, and y is by itself on one side of the equal sign. So that first step, I don't have to really solve anything. It's already there for me. Second step is to substitute. So I'm going to always put parentheses around whatever y is equal to. In this case, it's 3x. And I'm going to, instead of having a y down here in my second equation, it's going to be replaced with that 3x. Okay, that's going to be that substitution part. So in that equation, once I replace that with 3x, it's going to start with x plus, I'm not putting y down. Remember, I'm putting that 3x in there. I'm substituting that in. So plus 3x equals negative 32. Okay, so now I've substituted in, and I get to solve this equation. So now I'm down to one variable to solve for, which I can do that now. So I'm going to combine like terms. Remember, if there's an x by itself, I can put a 1 there. So this is really like 4x equals negative 32. And now I'm just solving an equation like we learned previously. And then last step is to divide by 4 on both sides. So x is going to be equal to a negative 8. Okay, but remember, solving systems of equations, I need an ordered pair. So I need an x and a y value. Well, I have my x value, or what I think is my x value. Now I need to use that in order to solve for my y value. So I'm going to take this negative 8 and substitute it into one of my original equations. Okay, it doesn't really matter which one, but by looking at them, this first one seems a little more simple, so I'm going to substitute it in there. So I'm going to come up to the top. So y is equal to 3 times x. Well, I think I already know that x is negative 8, so I'm going to substitute that part in so I can solve for y and have both x and y solve for. So now all I have to do is 3 times 8, which is going to give me, what, a negative 24. So right now I think that I have x and y equal to negative 8 and negative 24. And I'm going to go back to my original equations and substitute those in to check. Okay, that's my last step. Once I have my x and y value, I need to check them. So going back to my first equation, y, which I get as negative 24. So I have negative 24 equals 3 times x, which I got as negative 8. So I'm just substituting in those x and y values. Well, I'm asking myself, does this actually work out? Okay, does 3 times negative 8 give me 24? And it does. So I know that checks out with the first equation. Now I need to check the second equation. So I'm taking my x value, which is, again, negative 8, plus my y value, which is negative 24. And that it says it's equal to negative 32. Well, I'm asking myself again, does this work out? Is negative 8 plus a negative 24? Think about that about Dojo. If I'm at negative 8 and I get another negative 24, am I going to be at negative 32? Well, yeah, I am. So that is also going to work out. So I know for a fact that my ordered pair is negative 8, negative 24. And this is how I would write my final solution, as an ordered pair. All right, next one. So first step is to solve for either x equals or y equals. Get one of the variables by itself in one of the equations. Well, I'm looking at this equation. It's not as nice as the first one. So I'm going to actually have to do some solving. So I always look at the coefficients. Those are the numbers that are attached to the variables, okay? And then I also look at the last number. So I'm looking at each term, basically. I have a 6, a 2, and a 4. And then I have down here a negative 6, a negative 5, and a negative 28. When I'm looking at these numbers, a 6, a 2, and a 4 sounds like an easier number system kind of to work with than a negative 6, a negative 5, and a negative 28. So I'm going to go ahead and take this first equation, and I'm going to solve it for either x or y. Again, it doesn't matter if you solve for x or y as long as you have one variable alone. So I'm going to go ahead and solve for y. So I'm going to subtract 6x first from both sides. And that's going to cancel here, leaving me with 2y equals, I'm going to put that negative 6x first because I can't combine 4 and negative 6x because they're not like terms, so I have to keep them separate. And then that's a positive 4, so I'm going to just bring down that plus 4. Now at this point, y is not quite by itself. It has 2 times y, so I need to divide by 2. But I have to divide this entire side by 2 to keep things balanced. So here I have y equals, and then I'm looking at, okay, negative 6 divided by 2. Well, that gives me negative 3. And it still has an x, so that's negative 3x. But then I also have to take this positive 4 divided by 2. Well, that's going to be a positive 2. Okay, so now I have this equation that I'm working with, okay? So all I did was just solve that for y. Now again, whenever I solve for y, I'm going to put parentheses around whatever y is equal to. So right now y is equal to this quantity that's negative 3x plus 2. Now I'm going to take that quantity and I can substitute that in to my other equation for y. Okay, so I'm going to switch to blue. So the first part, all I did was solve for y just so I could do that substitution. Now I'm actually going to substitute that equation in. So I have negative 6x minus 5 times, I'm going to erase some of this, times y, which again is this quantity down here, that negative 3x. So I'm going to keep it in parentheses, negative 3x plus 2, and then equals negative 28. Okay, so now at this point I'm just solving because I only have x values in here, which means I can solve. So again, distributive property, so that's like a negative 5 times a negative 3x, which is going to give me a positive 15x. I'm also in the process going to just bring down that negative 6x so I don't forget about it. And then I still have to finish that distributive property. So negative 5 times a positive 2 is going to give me negative 10. And that's still equal to negative 28. All right. Now at this point, I'm going to combine like terms. So I have negative 6x plus 15x, which is going to give me, what, 9x minus 10 equals negative 28. I'm going to continue solving. So I'm going to add 10 to both sides. And that's going to leave me with 9x equals negative 28 plus 10 is going to give me negative 18. And then my last step here is to divide by 9. Divide by 9. And that leaves me with x equals negative 18 divided by 9 is going to be negative 2. So right now I believe that x is negative 2. But I need to solve for y, because remember my final solution needs to be this ordered pair where I have an x and a y value. So switching colors. Once I know what x is, I need to use that, okay? So once I figure out which equation I want to go back to, so I'm going to go to one of my original ones. Again, I'm going to choose this top one to go with. And notice that I'm not picking the one that I solved for. I'm not picking this y equals negative 3x plus 2. I'm going back to the original. Okay, so I'm going to substitute that in here. And I'm going to be in green doing this part. So I'm going to try to squeeze it in on the right-hand side. So I think that x is negative 2. So I'm going to substitute that in. So I have 6 times x, so negative 2, plus 2y equals 4. Okay, so again, my goal is to solve for y, and that's the only variable I have, so it makes sense. So now I'm just going to start solving. So I'm going to simplify this 6 times negative 2, which is going to give me negative 12. Bring down everything else I haven't used. Next, I want to get y by itself, so I need to take care of adding and subtracting. Well, I have this negative 12, so I need to use the inverse and add 12 to each side. That leaves me with 2y equals, well, 4 plus 12 gives me 16. And then last step is to divide by 2, that inverse operation. And that leaves me with y, 16 divided by 2 is 8. So right now I think that x and y are a negative 2 and an 8. So remember, my last step, since there's a lot of solving going on, right? So it's really important to go back and double check those to make sure that that x and y value actually work with the original equations. So that's what I'm going to do right now. So I'm just going to kind of go up here and write in some notes here. So like I have 6 times negative 2, and then 2 times y, which is 8. I'm going to see if that's equal to 4 here. Okay, so I'm looking at that top equation. So 6 times negative 2, well, that gives me negative 12. Plus, well, 2 times 8 gives me 16. Well, that does equal 4, so this is true. So I know that that first equation checks out, okay? Going on to my second equation. So again, I'm substituting that x in for negative 2 and that y for 8. And I'm going to see if that equals to negative 28. So negative 6 times negative 2 to start out with gives me 12. And then I have negative 5 times 8, which is going to give me a negative 40. Does that equal negative 28? 12 minus 40, yeah, that gives me negative 28. So I know that my final solution, I can finally write it in my ordered pair, is a negative 2, 8. Don't forget to write it as an ordered pair. All right, next one. All right, so again, one of my equations already is in a y equals format, so I don't have to solve for that. Next, that just means I'm substituting. So I put my parentheses around what value is equal to y, and substitute that in. So I have negative 4x plus 4 times x plus 4 is equal to 3. Now I can solve. So I'm going to get negative 4x. Just bring that down. I need to distribute next. So I have plus a 4x. And then 4 times 4 gives me a positive 16 equals 3. Okay, I'm going to combine like terms. So I have a negative 4 and a positive 4x here. So that ends up just giving me 0x or 0. I don't want to put anything down. That leaves me with 16 equals 3. Okay, again, you're asking yourself, is this a true statement or not? And no, 16 does not equal 3, obviously. So this is going to be one of those no solution situations. There's no good way of checking no solution. As long as you kind of go back and look at your work here, make sure that you substituted correctly and made sure that you combined like terms correctly and did your solving correctly. That's really the only way to check. Okay, there's no substituting in x and y. Okay, let's look at the last one here. So again, one of my equations is already in that y equals, so I don't have to solve for one of them. I'm going to put parentheses around that. And I'm going to substitute that in for y here. And that gives me negative 6x plus 2 times that quantity, so 3x minus 2, equals negative 4. All right, so I'm going to bring down that negative 6x, going to distribute, so that gives me positive 6x. And a positive 2 times a negative 2 gives me negative 4. And then I still have equals negative 4 here. Again, I'm going to combine like terms. Well, negative 6x plus 6x, then they end up canceling or giving me 0x or nothing. And I'm left with negative 4 equals negative 4. Okay, don't forget that symbol here. Well, again, is this a true statement? Does negative 4 actually equal negative 4? Well, yeah, it does. So this is going to be one of those infinitely many situations. All right, your next task is to do the maze and practice this strategy. Okay, you will be having a quiz sometime this week over the graphing strategy and the substitution strategy. So make sure that you're asking any questions that you might have, and I will be happy to help. Have a good rest of your day.